What's up, nerds? Thanks for staying this late in the conference, and especially for actually coming back after lunch. So hopefully I can keep you awake for most of an hour. This talk is titled The Anatomy of Java Instrumentation. And I'm Jason Plumb. My pronouns are he, him. I'm from Portland, Oregon. So thanks for having me all the way here for my first time in Poland. I work for Splunk, and I contribute to the Open Telemetry project. So a little bit of about here. We're going to do some background about observability, the history of Java instrumentation. I will go over a little toy library that I wrote for the purposes of this presentation, and then we will show the couple of different ways that we can go about building instrumentation to extract telemetry out of it. And we'll put it all together, do a quick demo, and we'll wrap it back up. Trigger warning, there are some depictions of human anatomy and physiology if you're uncomfortable with that, if you don't want to see a little bit of the inside of the human body. I'm not trying to gross anyone out, but if you're sensitive to that, now is maybe the time to choose a different talk. And yes, there are just some lazy slides of doctors and stuff in here too, so. All right, what this talk is not. It's not a full comprehensive guide on how to use OpenTelemetry. That would take hours and hours. It's also really intended to be more of a learning session about the internal workings of instrumentation within OpenTelemetry Java. And it's not a recommendation for you to go out and try and repeat what you see here. We've done a bunch of this work already, and I think that going and repeating it might be a mistake. So I'm not trying to encourage anyone to repeat the wheel here. So probably doesn't come as a surprise to anyone in this room that software is getting increasingly more complicated, and the environments that we push into are getting more complicated. This is a very lazy screenshot of some Netflix architecture that I found on the internet. There's lots of boxes. You can imagine every single one of those boxes being internally complicated as well. And on the left here is a screenshot from the Splunk network view. And it shows, I think this is Hipster Shop, and it's showing all of the interconnections between the various software components in Hipster Shop. I thought it made for a pretty good visual analogy with the internal circulatory system. And you could imagine that just like you might be interested in monitoring heart rate or blood pressure, you might also be interested in looking at, in your microservice, you might want to know the request rate or the throughput. So I thought that made for a pretty fun analogy. And much like a physician might use a stethoscope to look or to get some insight into what's happening inside the human body, we can use observability tools to figure out what's going on inside our applications and inside our networks. This term observability is a lot to come off the tongue. It has a lot of syllables, sort of like Kubernetes also has a lot of syllables. So we tend to scrunch that down. If you hear me say Ollie, that is the shortened form of observability after taking out the middle 11 characters. All right, if you're not familiar with observability and you've come to this talk, thank you. I will give you a very rapid-fire background of what this stuff is. You've heard people probably describe the three pillars of observability: metrics, telemetry, and logs. We'll start with logs because almost everyone has built or emitted logs at some point in the past. You probably can think of a log message as a timestamp, a severity level, and just some free-form text. And earlier in your career, you probably just said, this should not happen, or this part of the code is doing a thing, which is great. It's fine. Get a lot of mileage out of that. Splunk certainly has. And sometimes logs can be structured. You might want your text to be like a JSON blob. And then you might also want that to have a diagnostic context, which can be mapped back into trace context. And then traces, which maybe not everyone is familiar with. When we say traces, we could mean a trace within a service or within an app. We could also mean a distributed trace between multiple services connected together. But this is really a recording of a snapshot of a call context. So you could picture it as like a call tree, all represented as one big thing. That's a trace. Oh, in addition to just the tree itself. There's also durations of how long this calls took and a bunch of other metadata attributes associated with every span in that trace. And last but not least, metrics. You can think of this as an instrument looking at a certain signal and taking measurements at given points in time. Sort of like a EKG might be looking at heart rate. Similarly, you might be looking at request rate or error rate in your application. Counter, gauge, and histogram are the most common types here, and we usually do aggregations so that the data can be looked at in smaller time windows or larger time windows. And then the data also has attributes associated with it. Those attributes constitute different time series cardinality and can contribute to the cardinality of a metric set. All right, so rewinding a little bit. In the beginning was the Java agent. And maybe 15 or 18 years ago, maybe longer, vendors started selling these tools. And you could buy them if you were deploying software. And all it took was one line, one little tidbit added to your command line to get a bunch of really exciting telemetry out of your system. And it really did seem like magic. When I first used this thing, I was stoked. I could not believe the amount of insight that I could get just by throwing this one thing in there. And I had no idea how it happened and how it was built. And it was really this like secret sauce. But it turns out that secret sauce turned out not to be that secret, and people started figuring it out. And it slowly changed from being vendor magic to vendor lock-in. And so there's a bunch of companies doing stuff in this space, and there have been for a while. This is in no way comprehensive. I'm sure there's tons of other logos on here that I'm forgetting, and I apologize. But for a long time, everyone was doing things slightly differently. You can imagine one company calling the HTTP request verb the HTTP request verb. And you can imagine another vendor calling it the HTTP request type, right? And those two things would not necessarily be compatible with software that wants to visualize or do things with that data. So in the scope of observability, I thought these two numbers were pretty interesting. This came from a report that Plumb published recently on the state of observability in 2023. And it just kind of speaks to the newness. So 73, though, is a pretty good number. I like that number a lot. 14% is interesting, though. So I think that just gives us a little bit of perspective. All right, all of those vendors doing things differently. Some cloud vendors and some vendors decided, look, it's really hard to onboard a customer when they're locked into someone else. Cloud vendors are unhappy because everyone's doing things differently. So there was some effort to maybe start to go open source with this. There were a couple of early projects called Open Census and Open Tracing. Those were combined into a project called Open Telemetry. All right, we've come to the interactive portion here. How many people have heard of Open Telemetry before this slide? That's a lot of people. Okay, good. I like that. And then how many of you use it today in production? Also pretty good. I'm seeing like maybe 15 or 20. All right, and final one, how many people have contributed to the Open Telemetry project? Mateusz has, yeah. Okay, almost none. I don't see anyone else. Cool. There's a big project. There's lots of opportunities to contribute. Please check it out. There's the main website for Open Telemetry. I guess the stated goal, maybe the unstated goals, are to provide governance to an open source project because they don't run themselves. And then another goal is to omit a specification, so speccing out the shape of the APIs and how SDKs must behave in the various languages. Oops. And then providing a set of semantic conventions so that we all call things by the same name, so that we call HTTP request verb HTTP request verb, I think, except that's not what it's actually called. All right, and then there's lots of implementations for many different languages, and there is also a collector which serves as sort of a gateway and pipeline. All right, now that we're a chunk of the way in here, we can talk about the word anatomy and what that means. It is the study of the structure of the internal workings of something, and the something in this case is going to be Java instrumentation. So specifically, the internal workings of how the Java agent in OpenTelemetry works, and specifically how the instrumentation is constructed. So I talked about vendor magic. This Java agent, what is this? All right, final question here, like who has built one of these? All right, almost no one, this is cool. Some learning opportunities, I love it. All right, so Java agent is, it's nothing new, it's been around for 20 years. If you look inside the JDK source code, there's a copyright from, I think, 2003. And there's not you don't need to implement an interface to create a Java agent, but you do have to follow one of these conventions, and you have to implement a public static pre-main, which is going to be very analogous to your public static void main, except it's pre-main, and it takes typically 2 arguments. You can also, it'll fall back and do the other one, but in our case, we care about the first one, where we get some arguments and then an instrumentation implementation. Now that instrumentation class there, that second argument is pretty interesting. There's also a contract for doing agent main. We're not going to talk about that, but it's for attaching after startup. But the goal with pre-main here is that your pre-main will be invoked before the main method of the application that's running. So you can sneak in there before it. And then you have to tell the JVM which class is your pre-main class. So you put the name of it in your manifest, just like you would with a runnable jar and your main class. That instrumentation class that we had is quite powerful. You can do some very evil things, and you can carve pretty deeply. It has these kinds of methods on it, and I think those are probably somewhat legible. Add transformer. You can tell the JVM that you want to transform classes. You can redefine existing classes. You can change the order in which classes are loaded. You can change the order of class loaders. It's a pretty powerful and beefy, if not overly massive hammer. So here's the things that we care about that are in scope for this talk. Add transformer and redefine classes. Add transformer allows you to transform the bytes for a class. So this is what I visualize the Java agent doing. It's this bit of complicated machinery that then puts its tendrils into the brain of your application so that it's able to see what's going on inside there. All right, class file transformer is that thing we saw that's passed to your pre-main. And what's on that? Well, it has this transform method that's interesting. It takes in a class loader, it takes in a class, this protection domain, which we'll ignore, but really this class file buffer, this last argument here, this array of bytes, those are the raw class file bytes for the class that's being transformed by your transformer. And you'll notice that this also returns an array of bytes. So bytes in, bytes out, transformation. The Java spec has a class file layout. This is a bunch of very complicated bytes. And if you look in the spec, you can sort of see how this should be laid out. What a class file transformer does is take in those bytes, and you can imagine that really it's adding or changing certain pieces of the methods or other bits, but primarily we're concerned with the methods of your class. So there's new code in dark red here that's being injected into the class. All right, turns out the bytecode generation of that big structure is pretty complicated. And we do have some help from common libraries here. And the one that we use in Open Telemetry Java is the Byte Buddy. Byte Buddy has a class called Agent Builder. And it's a convenience API that allows you to sort of declaratively build up all of the operations that you want to do on various classes and when you get matched. And then these are all of the methods that you probably can't read on Agent Builder. So it's a very complicated process. We want to continue abstracting out some of that. It's because it is non-trivial to use these. So we have built our own set of abstractions in OpenTelemetry to help with this because we want to do instrumentation in a consistent fashion. This is the name of the project on GitHub. It's under the OpenTelemetry namespace or the organization on GitHub. There's links in the resources at the end for you. And within this repo, there are a lot of instrumentations. So every common library that you could imagine might be represented here. And we have handcrafted instrumentation for most everything. All right, so within instrumentation in the agent, let's dive into the different subsystems. I think of these as the two lungs of instrumentation. Bear with me on that one. On one side, we have library instrumentation. On another side, we have auto instrumentation. And whatever this thing is up here, I guess that's the agent. I don't know. And this picture lies a little bit because the left side here to your left should be significantly smaller. Like we don't have equal amounts of library and auto instrumentation, but I thought this was a pretty good metaphor. All right, let's talk about what library instrumentation is. So this is a way for us to create telemetry about internal workings of a library without needing to do bytecode weaving, so without doing class file transformation. If we are looking at a library that has been constructed in a way that exposes telemetry hook points, we will use those. So for an example, if you have a library that does like a request response type thing, whatever that might look like, HTTP, message queue, it doesn't matter. If you allow a callback to be registered, and that's called at the beginning of a request and at the end of a response, then we can wrap a span around that without having to bytecode weave. And you can use library instrumentation without the agent, and we publish all of these to Maven Central, and you can download them and use them. Typically, the topmost entry point for library instrumentation ends with a telemetry suffix. So if you're building foo telemetry, or if you're instrumenting foo.lib, your library instrumentation would have foo telemetry. Those will use instrumenters and this instrumenter builder to create an instrumenter. So that is a thing that does instrumentation. So I know we're just getting started here on this talk, but I'm going to do an early call to action, and that is if you write Java code and you are building libraries or applications, please put in hook points. Think about observability. Think about interesting places in your code that other people might want exposed, and put an interface there, give it a default no-op implementation, and then later on someone can build telemetry for that more easily. And then before we get into the quick demo here, just a reminder, this is not suggesting that you go and do this. If we have instrumentation already, please use it. Don't reinvent your wheel. This is intended to be an academic, like, learning exercise. All right, so we have, I'm going to start with this toy library that I made called Hospital Library, or Hospital Lib. And the first thing we'll look at is the data model. There are 3 classes that we care about. There's one called patient, and it has a name. And a patient comes into a hospital with a list of ailments. Ailments is just an enum of all the things that can be wrong with the human body, right? So you come into a hospital, you have an ailment. And then there are doctors, of course, who have a name and a list of specialties, which are the ailments that they can treat. All right, so there's the data model for our toy library. And now we can look at the API for it. The API for a hospital needs to provide these things. It needs to be able to tell when a doctor is available to treat patients, when a doctor is now unavailable to treat patients, and maybe a reason why. The ability to check in a patient into the hospital, the ability to check them back out when they're all patched up, and then this really interesting register patient listener, which is an observability hook point. So this allows a patient listener to be registered with the library. And let's see what that looks like. Patient listener has these methods. It gets called back when a patient has been treated by a doctor. It gets called back when a patient is checked into the hospital for a visit. And it gets checked out when the patient is all done. Are you with me so far? Pretty simple? All right, then we'll look at our example implementation of a hospital. And it is maybe the simplest example you can imagine. So we can create one of these example hospitals, and it's instantly started upon creation. And in start, it simply schedules its loop method. And in its loop method, all it does for eternity is to see if someone's in the waiting room. And if someone is, it tries to find them a doctor to work on them. And then if there are any active visits going on in the hospital, it tries to perform the treatment for that doctor session and then check the patient out if they're all patched up. All right. So finding a patient a doctor is pretty simple. We just loop through all the doctors and try and find one that has that as a specialty. And then same with starting a treatment, we just mark them active. We take the doctor out of the availability zone, and we perform a treatment by removing that ailment from the patient. All right. Hopefully this is a small enough toy for us to kind of understand. I hope so. All right, so what does instrumentation for this look like? Well, we have that nice listener, but let's go down and look at what we've created. So we're going to start by looking at the library instrumentation. One note, if you can see the directory structure here, I hope you can. It's a little small. This tries to follow the structure in the Java agent instrumentation repo. So in the cases where there is library instrumentation, we have peer directories called Java agent and library. So looking at library first, the top level class, as I mentioned before, is called hospital telemetry. And there's no interface on that. It just has a static factory method to create one. And when it's created, it uses this instrumenter to create an instrumenter that's passed to the telemetry. So let's see what create does. So create uses this instrumenter builder. This is a utility class from OpenTelemetry instrumentation APIs to create an instrumenter. And there's a few things that are interesting here. The first parameter is the instance of OpenTelemetry itself. The second one is the name of the instrumentation, and the third parameter here is an extractor that will take is a function that takes the generic item in and returns the name of the span for that generic item. In this case, it's a patient. So the name of the span being created for that patient will be their name followed by the word visit. That's a hospital visit because this is the hospital visit instrumenter. We also have an attributes extractor. That's a generic class that knows how to take in this case, a patient, and pluck attributes off of it to be able to put those onto a span. And in this case, we just care about the first name, the last name, and we put the initial count of the ailments that they had when they came to the hospital. Okay, and then we build it, and then we're back over to the telemetry. We had the instrumenter get passed to the hospital telemetry, and we see this public method. The way that a user of this instrumentation would use it is by calling observe hospital, passing it a hospital instance, and it creates for you a listener that is then registered with the hospital. And in our listener, when a patient checks in, when a patient checks in, we get the current context for OpenTelemetry. We ask the instrumenter if we should start. If we should, we go ahead and start, and then we put that into context in a global for later when the patient checks out, which we'll see down here. Patient's going to check out. We go back to the global, remove them from the global context, and then we end it with the instrumenter. And that should create a nice little span for the duration of that patient's visit to the hospital. So let's give it a test. Oh, we should look at the app. We should look at the application real quick. Yeah, let's do that. So there's a sample application that exercises our example hospital. It's called the Poke and Patch app. And, well, it's called two things stupidly on me, but it's called the Whizbang app, which is really a patch and poke app. And it takes in an instance of a hospital, and all it's doing is sort of kicking the tires and making sure that things work. It creates 3 patients with a variety of ailments, and then it will create 3 doctors who can treat some of those ailments. It checks them all into the hospital, and then it just waits for a long time for the hospital to do its work. Okay. With the instrumented version of that Whizbang app, we have some delegation here. So it creates an example hospital just like you would before, but then we add the instrumentation. And that's using the auto-configured OpenTelemetry SDK as our implementation. So when you're doing things manually like this, you still have to create an instance of the SDK yourself, but fortunately, we have this auto-configured OpenTelemetry SDK that has a bunch of sane defaults. So that includes like defaulting the exporter for spans to OTLP, among other things. We can then pass that SDK into our telemetry, and then that telemetry we ask to observe the hospital that we created for this app. So now that we've got that set up, let's give it a run. do you like that time is going backwards for some reason? Yeah, that's exciting. Cool demo. I mean, that's not going to change anything, but let's try it. I have never seen this happen before. Yeah, we just have to wait a while, I think, is what's. Oh, wow, that's exciting. Huh. That seems okay to me. Well, I've just proven the definition of insanity. Okay. Well, maybe we'll skip over that demo. I don't know how to fix that one. All right. Yeah. Okay. Say what? Okay. All right. I think it's worth a shot. So just clean as a separate step, and then run. Yeah, maybe. That's not a bad idea. Why not? I might have to restart the PC, like, honestly. Yeah. Oh, that's also a good idea. Mm-hmm. Yeah. We're doing it live. Oh, that's better. Wow, okay. Thanks, Mateusz. So hopefully we'll get some output. All right, there we go. We got our patients. They're checked into the hospital. We get 3 doctors. They're checked in, and the hospital's doing its work. And we'll see as their list of ailments for each treatment gets shrunk down. When they're done, they get released from the hospital. And in another terminal, I am running, not that one. In another terminal, I am running the UI here, so let's switch to that. And we can see if there was telemetry created using our library instrumentation. All right. So this is Jaeger. It's a very straightforward, simple tracing tool. And we see that, yeah, so this person was checked in. Let's dive into their trace. It's pretty flat and boring, right? There's only one level. There's no depth. There are no calls inside of it. But we see that this person, Robert Dobbs, was checked into the hospital at 1348. And if we look carefully, we can see that they had 1 ailment when they came in. Let's go over here to the next patient. Similar thing. We can see exactly when they came in. We can see that their entire duration at the hospital was a whopping 9 seconds. Good for them. And then we can also see that they came in with 2 ailments. And there's a little bit of metadata on this telemetry as well. It tells us where it came from, so the hospital lib, and it tells us what version of OpenTelemetry SDK we're using. Okay. Cool, but these are kind of boring, right? Like, they're flat, they tell us when they came into the hospital, but it doesn't tell us anything about their actual treatments during their stay. So we are going to want to dive into do some auto instrumentation for our example hospitals so that we can see more about their visit. Specifically, we want to look at when someone's being treated. So we can see start treatment here, and then later on we see a finished treatment. Those are the methods that we're interested in. If those had instrumentation hooks from the library, we wouldn't have to do any bytecode weaving. We could just tap into those and create telemetry. These are private methods. There's no instrumentation hook points. Well, okay, technically there is. I just have them commented out. But because these don't exist, we're going to have to do it the hard way. All right. Trying to connect. Yep. Yep. Okay. We're back. Okay. All right, auto instrumentation. So we looked at library instrumentation. We were able to run a sample app from a main method that was using that to hook into the library and get some telemetry out. We need to see more of this because we can't get any insight into what's happening during their visit. All right, so scrub in. We're about to go deep on auto instrumentation and how that's built in the Java agent. So at the top of the chain is the agent installer. The agent installer is responsible for loading all agent extensions. Agent extension is a way for third-party functionality to be bolted on to the existing agent without having to rebuild the thing. So there's a couple of ways that you can go about adding to an existing agent. You can do it by reshadowing everything into one big jar, including your stuff that you're contributing, or you could do it via extension. But in our case, the agent installer is taking each of those and calling agent extension extend, and that agent builder is that ByteBuddy class that we saw before. And then it just so happens that we have an extension within the agent itself called the instrumentation loader. It itself is an agent extension, even though it's bundled, it's a bundled extension. We use autoservice to find every instrumentation module. That's the name for every group of instrumentation. And for each of those, we invoke it, and they do that sort of declarative aggregation into the ByteBuddy builder, and then eventually that ByteBuddy builder installs on that blue instrumentation, which is that instrumentation instance that we saw from pre-main. So we're all the way back now to pre-main. So we've done this work of finding instrumentation modules, loading all of our instrumentation, then finally, boom, installs it on the JDK's instrumentation class. So I think mentally, at the top level, it kind of looks like this. Visually, agent installer extensions, module installer is used to install all the modules. And that big list that was scrolling earlier, that's all of the modules. All right, so what is an instrumentation module? It's an abstract base class that every module extends from, and it provides the name so that when you're looking at the metadata for some telemetry, you can tell where it came from. And it provides a list of matchers because we don't want to apply instrumentation to every class in the JDK. So this says, hey, I only want to apply in this one case. And then we have a list of these type instrumentations. What the heck is a type instrumentation? Type instrumentation is an interface for kind of attacking or going after addressing a single class that you want to pull data out of. And it provides type matchers, and it can transform using this type transformer. Well, guess what is a type transformer? The type transformer is an interface for a single type. There is one implementation inside of the agent. It's not something that needs to be built for every module. It's really just glue. But within this, we pass advice classes. And these advice classes use these ByteBuddy annotations, these advice annotations, to say when and where bits of implementation code should be injected into the target class being addressed. These advice methods are put on, these advice annotations rather, are put on methods, and they are also put on parameters. We'll see this in code in a second. If you look in the agent source code, you'll see that these are often referred to by their name, like as a string, and they are not directly passed to the transformer. And that is to sort of reduce the amount of, I believe it's to reduce the amount of class loading that's happening. All right, so a quick recap of what we just saw. Because there's a lot of like multi-syllabic words here, and they all kind of blend together in my brain, so I think it's important to have them like listed out. instrumentation module, type instrumentations, and advice classes. Those are the main things that you're going to see here when we look at the source code. And again, I kind of already covered this, but you don't need to roll your own distro. If you just pass this system property on the command line, you can add an extension to the agent. All right, we'll go back to the demo. Okay, so again, this directory structure follows what you would see if you were to look at the agent source code. And this Java agent class at the top level has its instrumentation module. So we extend from instrumentation module, and there's our auto service. This is what allows the agent to find us as an instrumentation. We pass our name to the superclass, so in this case, hospital lib, and the type instrumentations is the list of every instrumentation for every type that we care about. So in our case, we only want to go after that example hospital, so we just have the one type instrumentation. I kind of want to gloss over this, but in the event that you are not using this tool called muzzle to help throw stuff into the class path, or into the class loader correctly, you sort of have to override this method and tell it what your helper classes are. So in agent code, you don't see this too much. If you're kind of rolling it your own the hard way, you might have to say what classes you use. And that is because the way that ByteBuddy injects the bytecode is not straightforward, and you're not guaranteed to have these things in the class path otherwise. All right, let's dip into the instrumentation class. So there's that interface of type instrumentation, and we override or we implement the element matcher, the type matcher class. So we're declaring here that we want to transform a class named example hospital. And this is maybe the simplest transformer, type instrumentation rather, that you could build. There's only one type, and it's very addressable. In some of these larger frameworks, we have to go after a variety of interfaces and different hook points. So in this case, just the example hospital is all we care about. And we have 3 advices in this case. Our first advice that we care about is the start method. And we're using the start method in order to use the library instrumentation that we saw before to create top-level spans for every patient that comes into the hospital. So that's at start time, we register that listener from the library instrumentation. So this is a case where auto instrumentation is leveraging library instrumentation for the top level. And then start and finish treatments, we see those here. Those are also methods, right? So is a method, and it has this name, and it takes 3 arguments, and this other finish method. So this Fluent API here has a lot more stuff on it, and there's a lot of complexity to how you can target different methods and when. This is maybe also as simple as it gets. So what these are saying, though, is that in these cases, we want to invoke or leverage this advice. So we have this patient visit advice, the treatment starting advice, and the treatment finishing advice. And those are referenced, like I mentioned, by name as a string, although maybe I shouldn't have referenced the class here. Maybe that defeats the purpose. I think that should be spelled out. And patient advice, static inner class below. This is common practice in the agent. We see the advice here is telling it, we want this code to be placed right as the method is being entered. So you can imagine, it's not exactly this way, but you can imagine it being this bit of code sliced out and put in the beginning of that start method. Similarly, with the start treatment, take this code, put it at the beginning of the start treatment method, and then finally take this code on method exit, chunk that out, put it at the very bottom after the finished treatment, finished treatment finished has completed. Okay, so what's actually happening in here? Like, how do we go from this to spans? Like, we take this code and we plop it in there, but how do we link it all together? Well, the first thing we do is we peek into the patient visit context holder to get the patient, or the parent context rather. And that is the context that's tucked in there when a patient visits the hospital. So that is the root context for their visit. And we use that as the parent context for the treatments. So A visit is the root level span. Each treatment underneath that should be a child span. And we leverage a new instrumenter that we haven't looked at yet. And that is this treatment instrumenter. And the treatment instrumenter has a name of hospital auto instrumentation. It has its own attributes extractor. And you'll notice that the type is a little bit different here. Before we were looking at the type of instrumenter was around patient. This one is around something called a treatment. And that's just a three-tuple that helps to pull these three things together. And because a treatment does involve a patient, a doctor, and a specific ailment. All right, so on start, we pull out these attributes, the patient, the ailment, and which doctor is helping them. And then on end, we have nothing to do. All right, so that's our attributes extractor. Let's go back into our instrumentation, look at that. Start, put active. So we tuck this away in another global context just so that we have it around so that on end we can pull it back out and end it. Okay, so that's where we're at on that. One note here is that in advice classes, we definitely don't recommend putting lots of functionality. We want to keep those pretty thin, and we want to do a bunch of the work in helper classes. So you will often see a pattern referred to like as the singletons. It's because these are all usually public final static helpers that are used only within the scope. And this really shouldn't be public. It should be constrained so that people outside the instrumentation don't use it, but that's the pattern that we'll see. All right, I think that covers the things that are interesting about this instrumentation. I guess we didn't look at the instrumenter, so let's do that now. Just like the other instrumenter that we saw for the hospital visit, we have an instrumenter for a treatment, and this treatment instrumentation, or instrumenter, provides the name, and the span name in this case is the person and what they were being treated for, and that attributes extractor that we already saw. So we have another target that we can do here, if Gradle is going to be happy with us. And I'm doing this just in case, because I don't trust what happened before, but I have a target called run with agent. And let's look at the command line arguments on this. In our build Gradle, our run with agent, that's in the app itself. Stay with me, I know you got those lunch sleepies out there. All right, so we are passing the dash job agent command that we saw before, and we're passing in the open telemetry job agent. And a couple of system properties. The first one here is the extension itself, and then the name of our service. So those three kind of lines is all it takes to tell the JVM how to use the agent and also to use our extension. All right, we're going to do it. It's going to run. It's going to be good. All right, so same app. It's doing the same behavior. 3 patients checked into the hospital, 3 doctors able to treat them. Hospital does its work. Hopefully, eventually, everyone gets treated. And we should be able to go back into Jaeger. And hopefully, we have some new telemetry. It looks like 12 traces now. And even though these are the same people because we were in the same app, we hopefully will see a little more details inside of these, right? So now we see that this person came to the hospital, they had a stay, but we get a deeper observability into what happened during their stay. So this person came in with 2 ailments, and we can look specifically at these ailments to see what they were. So which doctor treated what ailment at what time and how long it took. So this is a much deeper insight into what happened within the hospital for these patients. So again, a toy example, kind of contrived, but hopefully you can see some of the power of this technique. I will also call out, because we're using the agent, we get a lot of additional metadata now, including the process ID and the thread ID and a bunch of other metadata that we didn't have when we were just using the library instrumentation. Okay. So just to recap, what have we done? We did a little background of what observability is and some of the vernacular around it. We leveraged anatomy as a metaphor. We showed how to build library instrumentation We showed how to build auto instrumentation, and we applied those to our toy library. We showed how that telemetry can come out and what it looks like in a UI. So here are some resources. If you want to check out the GitHub repo, it's public on GitHub. There's a link from that repo to the slide deck. And with that, I think I'll conclude. Thank you for your time.